Well, hello everybody. What I need to cover with you today is I need to cover section 4-5 and 4-6 with you. It's over the graphs of the sine function, cosine function, and the tangent function. We grouped the two sections together because they really flow nicely. So what you'll need to have in front of you is your day 6 class examples. Now, before I jump on those, let me show you what we're going to look at today. So if you would, grab your graphing calculator, hit your Y equal button, and then graph sine of x. Now, there's some settings that I need to show you first so it'll look like what we need it to look like. So if you would, after you have that in, hit your mode button and make sure that you're in radian mode for now. And then if you would, hit your window button. And in your x min and x max, we are going to go from negative 2 pi. So just type in that, negative 2 pi, and then it's going to change it to a decimal form, of course, to 2 pi. Now, for the x count, I'm really going to focus on the unit circle today because there's some key numbers on the unit circle that occur at every pi halves. So we're going to count by pi halves. You'll soon see that the range of the sine and cosine function is negative 1 to 1. So on your y, I'm going to give it negative 3 to 3. So here's where we're going to take you today. As soon as you hit graph, there's the graph of the sine function. We're going to do that by hand here in a minute, and then we're going to talk about some properties of it. Now that we have everything in the calculator, come in and let's look at the cosine of x. So I just need to change that because I'm still in radian mode and I'm still from negative 2 pi to 2 pi. So there's the cosine graph. Notice that it's very, very similar to the sine graph. It's just been shifted a little bit. We'll talk about that shift as we go. Now, we'll also look at the tangent graph today. It's a little different. So let's come in and look at the tangent graph also. And notice that's what the tangent graph looks like. The tangent graph has a lot of asymptotes in there, places where it's going to be undefined. Based on the unit circle, you will see those again. So there's where we're going. Now where I'm going to pick on first is we're going to pick on this guy right here, the sine graph. So notice what it looks like. Notice what its form is. It's all based off the unit circle. So if you would, come over to your first example right there. Now, I am not going to focus on these values today. Let's not worry about pi over 6, pi over 4, 3 pi fourths, 5 pi fourths, 7 pi fourths. Don't worry about those values. We can get the graph of the sine function 100 based off of the unit circle, which I have a picture of the unit circle right below. Now, remember, any point on the unit circle has coordinates of cosine theta, sine theta. We did a pairs check one day with about 20 of these on there, and you guys are really good at it. So here goes. My sine value are my y values. So I'm going to go get various y values. So the y value at x equals 0 degrees looks like 0. So if you would, put a 0 right there. Don't worry about rest of the columns. Let's come over to the next one that we automatically know. Let's come over to pi halves. The y value at pi halves is 1. Let's come over to pi. The y value at pi is 0. The y value at 3 pi halves is negative 1. And the y value back at 0, which is also 2 pi, is back to 0. Now guys, notice that as I do a loop, notice my values just keep getting the same. That's called a period. Now, come over to your graph, which is right below on yours. We're going to graph those key numbers. So at 0 degrees, you guys told me the y value is 0. So let's plot that, 0, 0. At pi halves, you told me the value was 1. At pi, you told me the value was 0. At 3 pi halves, you told me the value was negative 1. And at 2 pi, you told me it was 0. Now, guys, I can also go backwards on this unit circle. Or you could just continue a pattern, but let's go backwards now. Let's go get negative pi halves. If you notice the pattern going, it's going to go back down. It should be negative 1. Well, let's go this way. The y value at negative pi halves is negative 1. The y value at pi is back to 0. The y value at negative 3 pi halves is back to 1. And then I'm back to 0. Now, connect those dots in a smooth curve. Your smooth curve will probably look better than mine on this computer. And then, guys, right there you just got the sine function. We're going to list some important properties about this sine function. And I'm just going to do that right over here because it looks like you have a little bit of room there. Important properties about the sine function. These will show up on your homework, so make sure you write these down. Some important properties about the sine function. It's odd. Remember, guys, if we say that it's odd, that means we have symmetry about the origin. It means if I rotated it about the origin, this point would become that point. We rotate it 180 degrees. So there's symmetry about the origin. The domain of the sine function is negative infinity to infinity, meaning it's continuous. I can draw this forever without picking up my pencil. The range is negative 1 to 1. Notice I put those in brackets because we have values of 1 and negative 1. Now, this will look a little odd to you, but I'm going to say that the zeros of this, where it crosses the x-axis, notice it curves at 0, and then 1 pi, 2 pi. It's going to happen at 3 pi, 4 pi, negative 1, negative 2. So to write that, I'm going to say the zeros are at pi times n, and n is an element of the integers. N is an element of the integers. Now, the one really important thing, maybe one of the key concepts of the lesson today, the period of the sine function is 2 pi. It means it starts over every 2 pi units. Pick any point on the sine graph. I'm going to pick right there. Notice I'm here in the middle, and I'm ready to go up a hill. I'm ready to run up a hill. The next time I'm in the middle, ready to run up a hill, is right here. So it took 2 pi units to get there. If you wanted to see it again, if you start here, the next time I'm level is right there, 2 pi units later. So there's some important information about the sine function. Now, let's do the same thing for the cosine function. And of course, there's a cute graph of it. Now, let's pick on the cosine function. Once again, guys, I don't want to focus on that, or that, or that, or that, or that. I just want to focus on the main points from the unit circle. So once again, remember, any point on the unit circle has coordinates of cosine theta, sine theta. This time I want the x values. Well, the x value at 0 degrees is 1. The x value at pi halves is 0. The x value at pi is negative 1. The x value at 3 pi halves is going to be 0. Then I'm going to start again. My x value is back to 1. Now, let's come over and graph those. So here goes. At 0 degrees, you told me it was 1. At pi halves, you told me it was 0. At pi, we get negative 1. At 3 pi halves, we're at 0. And at 2 pi, I'm back to 1. Now, let's keep this pattern going the other way. So if I follow it, I know at negative pi halves, I'm going to be back to 0. At pi, I'm going to be back down to negative 1. Back to 0. back to 1. Now guys, we're going to connect that in a smooth curve again. So it's going to look something like this. Hopefully yours will look neater than mine. But there's what the sine graph looks like. I'm sorry, the cosine graph. Some key things to remember. The cosine graph starts at 1. The sine graph starts at 0. That's how I keep them straight. I remember sine goes through the origin. Now, some important properties about the cosine. This is an even graph, which means there's symmetry about the y-axis, meaning I can fold it over the y-axis and get the same graph. The domain is going to be negative infinity to infinity, while the range is going to be negative 1 to 1. The period of this, just like on the sine, is 2 pi. It starts over from an identical point every 2 pi, which makes sense if you think about the unit circle. Every time you do a lap, every time you go around. So the period is 2 pi. Now the zeros are a little bit harder to see on this one. So notice the zeros, they are at 1 pi over 2. They are at 3 pi over 2. I'm going to tell you there's another one at 5 pi over 2. If I come back this way, there's one at negative 1 pi over 2 and another at negative 3 pi over 2. Notice that the integers are all odds. So my zeros can be written like this. They occur at pi halves n, but n is an element of the odd integers. N is an element of the odd integers. So there we've got 2 of the 3 graphs done. Now, let's talk about that odd one, that tangent one. Let me show you why asymptotes show up in that. So, come over to your tangent one, and then guys, once again, we're only going to worry about the key places on the unit circle. Now, remember, we define tangent as sine over cosine. And then remember, your sine value is your y value. Your cosine value is your x value. So let's go look at what happens. At x equals 0, I'm going to have the y value over the x value. So I've got 0 over 1, which is 0. Now let's look at pi halves. At pi halves, I have 1 over 0, which is undefined. That's why an asymptote shows up at pi halves. Let's look at pi. I'm going to have 0 over negative 1, which is going to be back to 0. But at 3 pi halves, I'm going to have negative 1 over 0, so I'm back to undefined. And then back at 2 pi, I'm back to 0. So when we graph this here in a second, my zeros are going to occur at 0, at pi, at 2 pi. My asymptotes are going to occur at pi halves, 3 pi halves, 5 pi halves, you probably get that pattern going, negative pi halves. So come over to yours. I've already cheated just a little bit for the video. I drew in asymptotes at negative pi halves, 3 pi halves, and negative 3 pi halves. So I drew those asymptotes in already, just to speed the video portion of this up. Now, some more things that I know. My zeros occurred at 0, at pi, at 2 pi, at negative pi, and at 2 pi. Now there's a couple of different ways to think about this. If you think about your unit circle, the tangent is the sine over the cosine, so the y values. notice that my y values are growing from 0 to pi, but they're decreasing from pi halves to pi. The tangent function is really an increasing graph. So it looks like this. I've got to approach the two asymptotes. I've got to go through that 0. So here's what my tangent graph looks like. So I've got a branch that looks like that. I've got another branch that looks like this. I've got another branch that looks like that. Another branch that looks like that. And then another branch that looks like that. So that's what the tangent graph looks like. Some important features of the tangent graph: it's odd because there's symmetry about the origin again, meaning I can rotate this graph through the point 0, 0, and this piece would become that piece. In this one, there's no max and there's no minimum, meaning my range is from negative infinity to infinity. There's multiple asymptotes in this. I'm going to have asymptotes at pi halves n, where n is an element of the odd integers again. And then last but not least, zeros. This thing has zeros at every pi n, 1 pi, 2 pi, 3 pi, where n is an element of the integers. So guys, there's the main facts of the graph. One last important one of the tangent is the period of the tangent is just plain old pi. Not 2 pi, but plain old pi. Now, that's the hard part of the day, to be truthful. Now, come over to your number 1. Let me show you how easy we can make this. I'll probably do number 1 with you and number 3 with you. And we may talk about number 2. But the rest of this is really going to be pretty easy, guys. It says one solution to cosine of theta equal 0.226 is theta is 1.343. I'll show you what that means in the calculator. But right now, we must be dealing in radians. The reason I know that, theta was not given to me in degrees. So here's what that part means. If I type into my calculator, let me get out of this for a second, and let me clear the screen for you. If I go cosine of 1.343, I better get something really, really close to 0.226. And really, that should be an approximate, so that's book error. Now, I'm looking for some more values that would give me that same answer. Now, think about this. Since the period of cosine is 2 pi, here's how easy it is to get some more answers. I know that one answer is about 1.343. I'm going to add 2 pi to that. So it's going to look like this in your calculator. I'm going to take that 1.343, and I'm going to add 2 pi to it. So guys, there's another possible answer, 7.626. Let me show you. Cosine of that answer, I better get something close to 0.226. So one answer is 7.626. Let's say I want another answer. I'm going to take that 1.343, and instead of adding 2 pi to it, I'm going to add 4 pi to it. So I'm going to take that number I just had, 7.626. Let's add another 2 pi to it. So there's another possible answer, about 13.909. I could take my original answer of 1.343, and instead of adding 2 pi, I could subtract 2 pi. And if I do that, I got about negative 4.940. So there's an infinite number of answers in this problem. There's an infinite number. Just keep adding on 2 pi or subtracting 2 pi. Now, let's pick on B real fast. Use your graphing calculator to find all solutions between negative 2 pi and 2 pi. So this gave me some answers, but it may not have gave me all the close answers. So if you would, come into your calculator, and we are going to graph. So let me hit that. Let's graph cosine of x. And then in your second line, let's graph what we'd like for it to be equal to, 0.226. Now, something important here. Notice that it said between negative 2 pi to 2 pi. So I want to make sure my window is from negative 2 pi to 2 pi. Now, there's a lot of different ways to hit this from here, guys. So there it is, graphed. Notice that there's 4 answers. Notice that there's 4 answers. All depends on what you notice here. If you notice symmetry, you could find this answer right here and know that this answer right here is just the opposite of it. You could find this answer and know that that answer right there is just the opposite. So there's one way. If you find this answer, add 2 pi to it, you would get this answer. If you found this one and added 2 pi to it, you would get that. Or you could just second calculate 4 times. So I'm going to go second calculate a 0, up an intersection, and I'm going to come way over to that far left one. And I'm going to go enter, enter. So there's one of my solutions, about negative 4.94. Now I'm going to use symmetry. If he's negative 4.94, he's going to be positive 4.94. So I've got 2 of my answers already. Theta is approximately positive or negative 4.94. Let's go second calculate the intersection again, and let's get this one. Sorry about that little ticks on the video. Let's go enter, enter, enter. So I know negative 1.343 and the positive of it. So another 2 answers. Theta is positive or negative. What did I just say there? 1.343. So guys, that is if you notice the symmetry. Now, let's peek at your sine one, just so you can kind of look at it. I'm going to come back into my calculator. I'm going to graph sine of x, and I'm going to graph 0.785. So I'm really doing part B on number 2. So there goes the sine graph. Now, notice there's no symmetry in this one. But if you find this one, you could add 2 pi to it to get this one. And then if you find this one, you could add 2 pi to it to get that one. So if I go second calculate the intersection again, and let me come way over there again. And if you don't mind going second calculate, you can just do that 4 times. I want to get close to that one though. Enter, enter, enter. So I know that one answer is negative 5.38. I know one answer is negative 5.38. I know I could get another answer by going plus 2 pi to that. And if I do that, I'm going to get theta could be about 0.903. So I've just taken care of this one and this one. And to get my other one, let's go second calculate the intersection. I'll go get this one. So I know one of them is about negative 4.044. If I want to not work too hard and get that other one, I'm just going to add 2 pi to it, and I'd get that. Guys, if you don't mind, just go second calculate and come over to that. But my fourth answer looks like it's going to be about 2.239. Okay? Now I'll show you what the last one looks like, and then we'll have this video ended. I'm going to come into my y equal. I'm going to graph tangent of x, and I'm going to graph negative 1.773. Now notice the period of this one is pi. So guys, once you find one of them, if you find this one, we could add pi to it and get the rest of them, since the period is that. So you could find one, second calculate the intersection, and I'm going to go find the far left one. And I'm going to get negative 4.199. Once I have that, I'm going to add 1 pi, add 1 pi, 1 pi, and I have my other 4 answers. So, guys, there's what your lesson looks like. Now, we also did take a homework quiz, so we'll have to make sure we get you caught up on that. So, good luck. If you have any questions, make sure you get in and see us.